quiz. But I have the questions printed out here, so I'll just write the questions down on the board and we'll run through them now. Okay, so the first one I have, and when I printed them out, it just printed randomly, so I don't know, I doubt that this was the first question you had on your quiz. It was the one that said, the sum of the first 100 positive even numbers is what? So I had an AP, and I was looking for the sum of the first 100 even numbers. So I wanted you to work out, you remember this one? 2 plus 4 plus 6, etc. Yeah. So the formula is S100 is n over 2, 2a, and what's the a here? 2a plus n minus 1 times d. Yeah. And that was 50, that's 198 plus 4, 202? Which is 1,100? This? Yeah. Okay, so, oops. Oh, what was it, this? Is that what this is? 50 times 200, yeah, it's 10,000, so 10,100. Okay, I don't think this caused major problems for anybody, I hope. So the next one that I have in my random printout, don't access Moodle please, because it's running an update and it'll probably kill it if you try to access it while I'm running an update. This is dangerous. Okay, so number 2 for me. Need to write this down? No, we're okay? Yeah. Number 2, this one said, for what value of negative k will the quadratic equation have one distinct real root? Yeah? Yeah, you need the delta to be 0, the discriminant to be 0, because you want one real root. So, what confused a little bit, what was confusing for some people here a little bit was what's the A, B, and C. So the A is 1, the B is k, and the C is k plus 3. Yeah. So, guys, please, you too, guys, please, no chitter chatter. Are we listening? Listening? Are you not accessing Moodle, are you? No, good, okay, yeah, alright. So just listen, please. So, b squared minus 4ac, that should equal 0. Because we want one root. So, k squared minus 4k minus 12 should equal 0. So that's 6 and 2. So what's the answer here? Yeah, because I said in the question k is negative. Alright, 2 questions done already. Let's see what I have next. The next one is the third one. It was the root 2 plus 1 over the root 2 minus 1. I ask you to write it as a third. Can I scroll down? Yeah. Root 2 plus 1 over root 2 minus 1. Okay. So I'll multiply the top and bottom by root 2 plus 1. What is that called? Conjugate. So, multiplying out the top. Root 2 by root 2 is 2. Root 2 by 1 is root 2. 1 by root 2 is root 2. And 1 by 1 is 1. Root 2 by root 2 is 2. Root 2 by 1 is root 2. Minus 1 by root 2 is minus root 2. And minus 1 by 1 minus 1. So, on the top, I'll get 3 plus 2 root 2, and on the bottom I'll get 1. Because they cancel, yeah. Which is 3 plus 2 root 2, the answer. Yeah?
Is it okay if you say minus root 2 plus minus root 2 minus 1?
On the top?
Yeah.
And minus root 2 minus 1 on the bottom?
Yeah, like.
Yeah, that's okay. That's okay. Oh, I see, yeah, because you're changing the sign on the root part. Yeah. Technically that's the conjugate. But it just works out to actually change the sign on this guy alone as well. But you're right. You said minus root 2 minus 1. You should get the exact same answer at the end. That's 100% fine. That's a little bit more like what I actually did in class. Yeah. But all those minus signs, just
That minus is maybe minus 3 minus 2 root 2.
No.
Or minus 2.
Yeah, okay, and then you can get it in the next line. Yeah. Okay, you have this written down? Yeah? Am I waiting for anybody? That's okay? Yeah? Okay. So, number 4 for me in my printout is the cubic x cubed minus 1 is divided by x minus 1. What is the result? Long division it is. X minus 1 divided into x cubed. Now, some people may like to write 0x squared, 0x minus 1. I don't feel any huge need to. I mean, you can if you like. If this makes it easier for you, that's fine. Yeah? Yeah, because I don't have any x squareds or x's in this. So I say I have 0x squared and 0 x's in it. If you don't like this, don't do it. It's just some students learn.
We can do 1.
You can, like this?
1x.
Nah, because there isn't actually a 1x here. No, the only reason I said about the zeros is some students would have seen that in high school. So if you did, that's fine. I'll keep it this way though. What do I need first here? It's an x squared, isn't it? So this is x cubed minus x squared. I minus them and I'm left with what? Minus 1. So next is x squared minus x. And I'm left with, so the last guy is 1. Yeah. Now, you have to be careful. I very specifically said how I wanted the answer typed in. So I wanted you to give me the answer in the form of A, B, and C like that. Do you see? Oh, no, you don't, sorry. AX squared plus BX plus C. I said I wanted AX squared plus BX plus C. So you really should be giving me the answer like this. Now, guys, you need to be careful about this because they do this in the exam sometimes. You know, they would, if they said, give the answer in this form, then they want you clearly to state the A, B, and C. Now, some students will do this. They'll say A equals 1, B equals 1, C equals 1. Fine. That's fine if you do that. Or, you could do this. 1x squared plus 1x. Huh? Yeah, because now you see, you need to be careful in the final exam because they sometimes will say, give your answer like blank, and your answer needs to match exactly the format that they asked for. So if they're asking you to specify the coefficient in front of x squared and x, then that's what you need to do. Okay?
So for like the test we did, if you wrote like the x squared plus x plus 1, is that wrong?
I might have given you the mark for it. I can't remember because I need to review the quiz. But my point is, in an actual final exam, if you did that, you have a chance of not getting full marks for the question. You know? Yeah. And I noticed a couple of people did that a couple of times where the question very specifically said, give your answer in this form, and they didn't. And they said, but that's okay, it's the same answer. I'm like, yeah, but give the people what they asked for. So if they want it in a certain form, give it in a certain form. You know, I don't know, who's your English teacher? Is it Connell? No? Neil? Maybe, I don't know if you learned this in EAP. Has anybody shown you this in EAP yet? No, you haven't learned about this. Okay. It's an exam technique, alright? The R stands for read, the T stands for there, the Q stands for question, and the F stands for something I can't remember right now quite accurately. Okay? So, if they ask for a particular format, give it to them. Yeah? No bad language. Okay, next question now. Right, so that was number 4. Okay. Can I scroll down? Yeah. Alright, number 5 for me. Number 5 was where I had x minus y equals 7 and x squared plus y squared minus 25 equals 0. And I think I said there's 2 answers. Give me the answer where y is bigger than x. Yeah. And in fact, this question was answered quite well. I think most people got this one right, so good job on this.
3 and 4.
Yeah, it was 3 and 4. Yeah. We have to rearrange the first equation, so we could say y equals 7 minus x, and put that in here. So you have x squared plus 7 minus x squared minus 25 equals 0.
Sorry.
Yep.
That's y plus 7 minus x there.
Did I do that backwards? Sorry. Y equals x. I did it backwards. Thank you. In fact, I did it backwards, but I still get the right answer because of the square. Yeah. But we'll write it properly. Thank you. Y equals x minus 7. Yeah. So you have x squared plus x minus 7 squared minus 25 equals 0. So that's x squared plus x squared minus 14x plus 49 minus 25 equals 0. 2x squared minus 14x plus 24. So that's x squared minus 7x plus 12 equals 0. So what do you get? 3 and 4 here. X equals 3 or 4. So then you'll get y equals, by using this formula, 4 or 3. So this is the answer you take. So, and again, I said give your answer in the form of bracket x comma y bracket. So the answer is 3, 4, like this. Okay. That was a good one. Everybody did very well on that one, so that's good. Number 6 for me, coming up next, is the GP question. So it's what is the sum of the first 10 powers of 3? So that's 3, 9, 27, 81, and so on. Okay. Can I scroll down? Yeah. Okay. So this is number 5 for me. I wanted 3 plus 9 plus 27 plus 81, ... and there was 10 of these numbers. So the formula for S10 in the GP is A, 1 minus or n over 1 minus or. Now we can hit this in on the calculator here. I'll show you. You have it? Well, I'll just put it on the calculator so for people to see. So it's 3 bracket 1 minus 3 power 10 over 1 minus 3, 88,572. Is the answer. Are you okay? Well, you realise the mistake you made? What did you do? No, let me guess. A common mistake I make is sometimes I put the 10 down here. No, okay, what did you do? Oh, that's terrible. Okay, heartbreaking. Right, that was actually number 6. Okay. Number 7 was just 2 linear equations for me. Can I scroll down? So number 7 was 2x plus 3y equals 10. And x plus y equals 4. I think the easiest thing to do is to multiply this one by 2. So you get 2x, 2y, and 8. And then you subtract. So that's y equals 2. And you sub that back into x plus y equals 4. So you get x equals 2. So the answer is 2, 2. Maybe I made these too easy, huh?
No.
Some of them, yeah. Some of them.
There's
My question.
I thought I was being funny with that question, and I gave you a hint. I gave you a picture as well. Yeah. Okay.
the
Next.
notations one or number five.
Which one?
The notations, yeah, the set notations. I was pretty sure of my answer, but
Okay, let's have a look.
Well, maybe some people need to put like X into the set notation.
the one and two.
Maybe did you put like X is remember?
Yeah, but the set
I think I maybe accepted both answers, but I was kind of imagining students just to type in the set.
Yeah, I did that wrong. So
Yeah,
I put the X into notation.
And marking this right. Well, there were some problems with the quiz, but I'm running an update on Moodle right now, so hopefully I can fix the quiz for anybody who wanted to retry them as a homework. But anyways, number 8. When the cubic x cubed plus px squared plus px minus p is divided by x minus 1, the remainder is 2. So what do we have to use for this one? Remainder theorem. So if you put in what value of x here? 1. So 1 cubed plus p times 1 squared plus p times 1 minus p, that should equal 2. So that's p plus p minus p plus 1 equals 2. So p should equal 1. Yeah. Did you say 3 in the exam? No, okay. Type your answer in as p simply. So just type in 1 is all I wanted. Okay, that was number 8. So that's okay. Number 9 was a factorized question. And I'm sure some of you didn't, or perhaps used the graphing calculator to help you factorize here. Some of you used the Casio 991 calculator to factorize and forgot about the signs. So you either, what did you do? You didn't change the signs, was it? Or?
I said that I have to flip the signs, but then when you told me, so I changed my answer.
You fixed it then, yeah. So, if you're going to cheat and use the calculator, at least make sure you do it right. So, number 9 was to factorize 2x squared minus 5x minus 12. So let's do this the honest way. Has to be a 2 and it has to be an x, because I need the 2 here. Now 12, it could be 6 and 2 and 4 and 3, but I need to make a 5 in the middle. So if it was 6 and 2, I could get a 4 and a 6, or a 12 and a 2. No, that's too big. So it has to be 4 and 3. Yeah, actually an 8 and a 3 could go together to make a 5. I need a minus 5, so this will be like this.
Yes.
Now, if you read my question, I said give the answer as ax plus b times x plus c. Yeah, so in other words, I was kind of hoping that nobody would type the answer like this, was my point. Even though it's right. Okay? And the reason was I was getting bored imagining all the different ways students could type in the answer. So I wanted the bigger one first.
The exam gave me when I first submitted it,
Yeah.
I put it like that and it gave me wrong.
Are you sure?
Yeah.
Did you put in spaces?
No,
Are you sure?
I'm pretty sure. That's what I came up to you to tell.
Okay. Well, I'm fixing it anyway, so. Okay, number 10 was Pascal's triangle. There was one number missing. Yeah, it was 6. Yeah, well, I threw it in, keep you happy. And number 11 was, I just wanted you to use the calculator.
2.7.
Yeah, it was 2.7 was for this one, on the calculator. Yeah. Yeah. Pascal's triangle, there was a number missing. Do you remember that? Yeah. Huh? 11?
Yeah.
Ah, no. Watch. Shh. I haven't typed anything yet. Shift 0 to 10. 1 over alpha x. Where's factorial on this? Here it is, up the top. What did you do wrong? Ah, so you just added number 1 to itself 11 times. That's why you got exactly 11. Why'd you put in 0 factorial?
So like x is equal to 0.
It starts at 0 and goes up to 10. Yeah. Question over here? No?
First I wrote in my answer, 11 was wrong. So I thought, then I read the question was like,
You got 11 as well.
yeah.
Ah, guys, okay. Right.
So how do you view your calculator has no function to sum up?
Yeah, you would have to do it manually,
Okay, yes.
bit by bit by bit. Yeah. By the way, as a side note here, if anyone's curious, if you were to continue the sum infinitely, the answer would be this, by the way. So, if you knew that, you wouldn't even need a calculator then. Okay, so 12. The line L is perpendicular to the line that passes through the point 1, 1 and -1, -1. So you have a line here, and I think it goes through the origin. And your line L is perpendicular to this and intersects the y-axis at 2. At 2. And my question is, where does it intersect the x-axis? Alright, so first things first. Guys, no, I'm stopping now because I have too many people talk when I'm talking. So I need you paying attention. Okay, so first thing I'll get the m. So that is by using the formula y2 minus y1 over x2 minus x1. So that's going to be just 1 minus minus 1 over 1 minus minus 1. Which is 2 over 2, which is 1. But for this line, it's perpendicular, so minus 1. Y equals m, which is minus 1. Now, actually, you know what the c is for this red line? 2. Because I tell you it's where across the y-axis. So where do I find where it crosses the x-axis? When y is 0. So x will equal 2. So the answer is 2. Okay. Okay? Yeah.
When you say give your answer on x only, can you say something like x because it's
Just 2.
just
2, yeah. Okay. It's okay? Question? Go ahead, Jim. Are you sure? You can ask me. Are you sure? Alright. 13 now was the inequality question. Let's look at that one. Okay, so I said x cubed minus 3x squared plus 3x minus 1 greater than or equal to 0. And the tip I give you in the question, my hint in the question is sketch it. Because if you can sketch it, then you can see the answer more clearly. So, what do we do here first? So, how many people here try to guess and find a root first? Did most people do that? No? Yeah?
I used the calculator to do cubic fact, like to factorize.
Okay, fine, yeah. Which is the same thing as, yeah. But I was hoping, I tried to make this one easy for you, because I was hoping somebody would actually spot that it's 1331. So this is actually x minus 1 cubed. And when is a cubic positive? When this part is positive. Because if you cube a negative, it's negative. If you cube a positive, it's positive. So you just need x minus 1 to be positive, which means x needs to be bigger than or equal to 1. So the answer is this.
That's what I thought.
I know. Do you not remember me saying 100 million times that the quiz needs to be fixed? I'll say it 100 million times plus 1. You need to fix the quiz. It's updating right now. 1 to infinity. Now, those students who sketched it, you would have gotten this sketch.
Yes.
So you would have, sorry, that's not quite nice. You would have gotten something like this. So it would have been from the region 1 to the right is where it's positive, if you sketched it. Or even if you had some kind of graphing calculator of some sort here, yeah. Okay, so that is number 13. Right. Do you have this written down? Yeah? Okay, 14 now. This is the question where I said 2x plus 3y power 4 equals 16x4 plus 96x cubed y. What have I got? Plus 216 x squared y squared plus kxy cubed plus 81y4. And I asked you for the k. So actually this is just a way of me asking you what's the coefficient for this guy. So if you examine this, you realize, well, firstly it has to be a 4c something. So what's the something here? 3. And then you realize you have a 2 and a 3 with an x and a y. Yeah. But what goes on the 2 and what goes on the 3? 1 and 3. Because you needed the x to have a 1 and the y to have a 3. And this 2 comes from the x and this 3 comes from the y. So it has to be this way around. When you bashed this in on the calculator, what did you get? 216 as well, was it? Okay. So the answer is 216 then. 15. What number comes next? 3, 1, 4, 1, 5, 9, 2, 6, 5, yeah? I have no idea. No idea.
I just put that into the calculator and got the
Brackets. Try again with brackets. Now this one here, okay, it was 4, and you can get this from your calculator by typing in pi. But actually, if you're being more technical about it, pi's value is 3.141592654 So really, 5 3 and then something beyond 3, like I don't know, like a 5 again or something. The calculator is actually rounding the 3 up to 4. So if you typed in 3 or 4, that's fine. But I was figuring that most people will get the value of pi on their calculator, which says the next digit is 4. And there was a picture of a pi in the question as well. So you all got my joke in it, didn't you? Yeah, okay, good. Right. Next, can I scroll down? So 16 was, I wanted you to solve this, and you can solve it any method you want. I think this has factors, doesn't it? X minus 2. Yeah, now, I just assumed everybody would type in the answer x equals 1 and x equals 2, but some people typed in 2 and 1, which I didn't consider. So either way is fine. 17. Now this was a tricky one. This one caused a great deal of confusion. For some small positive natural number n, the quadratic equation 2x squared plus nx plus 2 will have two rational roots. Find the smallest such n. Is it? What will it be? There you see, it cannot be -4 because...
I did actually, in the first one I did this. For some, I don't know why, I just saw rational roots and I did greater than or equal to.
Yeah, some people did this.
Yeah.
Some people looked at the discriminant, yeah? Yeah, but that's not right. Because, I'm waiting. Some people type in greater than 4. That's not right, because you need to read the question carefully. I said, now listen, everybody listen. I said, for some small positive natural number n, the quadratic will have two roots, rational roots. Find the smallest such n. I didn't say find the range of n. I didn't say what's the possible values of n. I said find the smallest such n. I was looking for the smallest n possible. So if you said n is greater than 4, or greater than equal to 4, which one was it? Greater than 4, then your answer should have been 5. Because that's the smallest number greater than 4, you know. And again, they do this in the exam sometimes, you know, where they would say, what is the smallest possible answer? And students would say, oh, n is greater than 4, and, you know, they would lose a mark.
And I put that and I said this was wrong, and I hate this question. And I sat there for like half an hour trying to fix it.
Would you like me to repeat for 1,000,002 times?
Sorry, Stephen.
Yeah.
You know how like the answer was written for?
I haven't calculated the answer. The answer might not be greater than 4. Let me calculate it first and see, okay? So, I said find the value of n that makes this equation have rational roots. So, what is the roots here? It's minus b plus or minus the square root of b squared minus 4ac all over 2a. Now, listen.
Over 4.
Listen. So, you're looking for what is the smallest number that will make this have rational roots. A rational root means a fraction without the surd, without the root. So one way you can cancel this was just have it equal to 0. So you can easily get that if n equals 4. So 4 is the answer. Now, if I can't remember if I think there might have been an error in this one here. Did somebody type in 4 and say it was wrong?
No, it's actually two rational roots.
I'm wrong. Thank you. No, thank you. I forgot that I actually said it needs to have two rational roots. So I can't use 4. Yeah, you did the same thing I did. That's funny, and I made the question, and I deliberately put that in to catch people out, and I caught myself out. So it needs to have two roots. So we can't use 4, because if we use 4, we only have one root. So we need n squared minus 16 to not equal 0, and we also need it to be equal to something else. We need it to be equal to a square number. Now, why am I saying that? Yeah, that's it. Because if this was equal to a square number, what's the square root of a square number? It's a natural number. Like square root of 36, square root of 81. These are all natural numbers. So there's two ways I can get rid of the square root. I can get rid of the square root by making it 0, which I'm not allowed to do, or by making the inside a perfect square. So we know that 4 is no good, and we can't be less than 4. Why can't we be less than 4? No. Why can't I be less than 4? Come on, it's obvious. Look at it. Why can't I be less than 4?
Because
it'd be negative then, which I can't be. So let's see what happens if I put in 5. So 25 minus 16. What's that? It's 9, isn't it? Is that a square number?
Yeah.
Yeah, so a 5 looks like it'll do. Now, you might say, oh, hang on, maybe there's more answers. Doesn't matter. If there's answers after 5, I don't want them, because I asked you for the smallest such answer. The smallest such answer. Can there be anything less than 5? No, clearly. Clearly there can't be anything less than 4, and we said we can't use 4. What about 4.5? Could we use that? It's not natural. So, really, if you think about this, it has to be 5 there, and nothing else it could be. Now that was a tricky one. That was a tricky one for sure. They can't all be easy, you know. Okay. Yeah.
Can we use the discriminant formula?
Yeah, and what would you say?
B squared minus 4AC
Yeah.
more than 0.
No.
But I got it right.
No, but b squared minus 4ac more than 0 just guarantees that you have 2 roots. It doesn't guarantee that the roots are rational, because the roots could have been decimals. Now, if you got the right answer, you got it for the wrong reason.
I did the same thing, but
Yeah, but for the wrong reason.
so it's better to use this.
Not that it's better, but it can only be this way. Yeah. So in that way, it's better. Yeah. There's something in maths called type tree error, I think. Type tree error is when the student gets the right answer but for the wrong reason. So they got it just by accident. It's a type tree error. Okay. Next.
Do you get more stuff like that?
Not really. 18. 2x squared plus 12x plus 22. Complete the square. So, take out the 2. Complete the square. And put back in the 2. And that's the answer.
A lot of people messed up when, like, I noticed that they didn't multiply 2 by 3.
Yeah. That's a slip up, all right. Yeah. Okay, got that? Yeah. Okay, 19 now. 19 was that I asked you to solve this. And I tell you that. Yes.
I got +2 for the last one, which you guys.
Got what?
I got +2.
What do you mean plus 2?
Because,
At the back?
yeah, I got. Oh yeah. Okay.
Yeah. Now, hang on. You're not listening, because Mo just said a lot of students made the mistake of forgetting to multiply the 2 by 2. Okay, so when classmates are talking, you need to respect that they might have something valuable to say. Even if they are Mo, he could have something valuable worth listening to. I'm standing up for you, okay? Right, so when a classmate is asking a question, this doesn't mean you stop listening, okay? They might have something worth listening to. Okay, 19. So this one here, I tell you that n is a non-zero natural number. Figure out what the possible values for n are. Give your answer as a set. Okay, so I think really we have to split this into 2 problems. 90 less than 3n squared plus 30n minus 27, and 3n squared plus 30n minus 27 less than 198. So here I get 3n squared plus 30n minus 117, minus 90 minus 27. Yeah, more than 0. And here I get 3n squared plus 30n minus 225 less than 0. Now this can be divided by 3, and this can be divided by 3. So n squared plus 10n minus 39, n squared plus 10n minus 75 less than 0. Now this has what solutions? 10 and 3? No. So if you were to mark them on the x-axis, what would it be? Minus 13 is 1. And the other one? 3. Okay, and we want to be above or below? Below here. Oh, sorry, thank you. Sorry, I'm thinking about lunch right now. Above. Okay. This one here, what did you get? 25 and... 5 and... minus 15. Okay, and above or below here? Below. Right, so we're looking for situations where we can have both shaded regions at the same time. And ask for natural numbers. Okay, so first things first. We can completely disregard negatives because straight away we're only looking at situations that could be positive. So according to this, x has to be bigger than and actually not equal to 3. So we could have 4, 5, 6, etc. Here we want positives which are less than 5, not equal to 5, and not 0. So we could have 1, no, we can't have 0 because I said in the question it's non-zero. 1, 2, 3, and 4. So what are the situations when we have both? Only 4 overlaps. So if I was to give 4 as a set, the set of possible answers is simply this, because only 4 is the possible answer. Did people get 4 here? It was a tricky one.
I'm not sure because this one sometimes different.
Yeah, but the key thing was, I said in the question, give your answer as a set. Yeah, and 4 by itself isn't a set. It's a natural number. Yeah, question?
No, I use open brackets because it's a set.
Yeah, but that would include numbers which you're not allowed to have because I said natural numbers only. So you're saying everything between 3 and 5. Yeah.
It would include it if it says it's greater than or equal to. Then you choose here.
If I didn't say it was a natural number.
Yeah.
Yeah.
If you said it's greater than or equal to.
No, she wouldn't be. Well, what type of brackets did you use? Curly brackets? Open brackets. Yeah, so. Yeah. Yes, if I changed it to this, I would have more answers, wouldn't I? What answers would I gain? I would gain a 3, and I gain a 5. Yeah, so I'd have 3, 4, and 5 as an answer then, yeah. Okay, 20 now. So I said, find the equation of the line that passes through 1, 9, and 8, 4. And the thing that really caught people out, which annoyed me, is I said, give the answer in this form where A, B, C are natural numbers. Now they do this in the exam all the time. They would say, give it in this form where A, B, C are natural numbers. Now some people gave it to me in this form, but A, B, C were fractions. And they were very indignant about it. They said, what? I gave it in the form that you wanted. What's the problem, teacher? And I said, well, they're not natural numbers is the problem. So if I ask for natural numbers, or if they ask for natural numbers, that's what you need. So, anyways, what will we do first? We'll get the slope. M equals y2 minus y1 over x2 minus x1. No, I'm just waiting. While you're talking. So, this will be minus 5 over 7. Y equals m x plus c. What's the easier one to use to get the c? 1 and 9, 'cause there's a 1 in it. So I have 9 equals minus 5 over 7 times 1, which is still the same. So what's that? 63 and 5, 68 over 7, is it? So c equals 68 over 7. So I have y equals minus 5 over 7x plus 68 over 7. Now if you stop there, that's wrong. Because they're not natural numbers. So what should I do next? Multiply by 7. I'm going to wait while people are talking. 68. Now, it actually matters a great deal here. Do I take the x to the left or the y to the right? Yeah. Now, just so you know, you might be saying, what difference does it matter? So if I took the x to the left, I get 5x plus 7y equals 68. But if I took the 7y to the right and the 68 to the left, I would get minus 5x minus 7y equals minus 68. Now, that answer, although it's the same, I don't want the answer in this form. Why not? Natural numbers. And negative numbers aren't natural numbers. So this and only this is the answer. Because only this matches the form I asked. Coefficients are natural. Yeah. Okay. And that was number 20 now. Any questions about any of those 20 questions now that anyone needs clarifying? Yeah.
For the NCR question, I'm still getting 72.
Oh.
Even though I use brackets.
Okay. Maybe. Let me check it for you. You're saying this one here, yeah?
Yeah.
Okay. Now look. Guys, we need to show respect to our classmates, because like I said, if someone's asking a question about something, there's a good chance you will find something valuable in it. So, what I'm going to do, I'm going to type this in, and I want you to see if what I type in matches what you typed in and where the problem could be. So, you said even with the brackets?
Yeah.
Okay, let's have a look. Is it possible this is wrong? So, that's 4 shift C3 bracket 2 bracket 1 3 bracket 3 like this 216. Now I know, but play it safe. Because I have no idea what order the calculator will do this in. Like, for example, will the calculator first do 3 times 2 times this and put that into the C? Or will it first get the C and then times, like, you wouldn't know for certain what the order of operation is involving the C here. Like if I wrote down 3C2 times 2, if I wrote down 6C2 times 2, clearly I want you to do this and then this. But if I type in 6C2 times 2, do I mean 6C2 times 2, or do I mean 6C of 2 times 2? So you just wouldn't know with the calculator unless you use brackets. Now, what went wrong for you? Okay. Question? To the last one I did? Yeah. This one here? Hey. Oh, you just need to write it down. It's not a question. Oh, okay, alright. And Chad, would you like me to strangle you with your scarf? Because you see, I'm getting very hungry, so I'm very irritable, so please, don't risk your life, okay? Right, Sarah, did you got this, or do you need a minute? Yeah. You need me to scroll back to 16 to write it down, or because you have a question? Just want to check something, yeah. Can I go back to 16? Yep. Right.
So,
Who's asking me a question? Yeah?
you said something like, which I was saying, x
No, it's very interesting. A lot of people misread that. I said in the question, okay, this is what I said. I said in the question, write your answer in the form x equals x1, comma, x equals x2. So I wanted students to write in x1, x equals 1 and x equals 2. But for some reason a lot of people read this and in their mind they saw to write x1 equals 1, x2 equals 2. It's as if they read this and the suffix jumped to the left. That was a very common thing. Like I think 25% of students did that. I don't know. So again, I just bring you back to my advice from earlier. Okay. Right, can I close this now? Yep. Okay. Right. Let's see. So we'll start. We have to finish the chapter on indices and logs.